Hey guys, today we're going to do inverse functions, and I know that this says day 1 and it's really our day 3. Don't worry about that. I just wanted to add a little bit to the lesson that they have provided. So we're going to start with inverse functions, and what does that mean? The function that results from switching your x and y variables in a given function is what an inverse function is. So the inverse of f of x is written as f, the inverse of x, and this little f of -1 represents that inverse notation for the function. So if you look at this table, when we have a function, if you'll recall, for every input value, there's exactly one output value. The inverse of that is simply switching your x and y values. So here we had an input of -3 and an output of -17. The inverse is going to have an input of -17, the output of -3. So again, with a table, your x and y values are switched in an inverse function. Alright, so now let's talk about a one-to-one function. If you recall, a function passes the vertical line test. Okay? A function has an inverse if it is one-to-one. So you're saying, okay, well, what does one-to-one mean? Well, a function is one-to-one if every x is assigned exactly one y and every y is assigned exactly one x. Graphically, that means it's going to pass both the vertical line test and the horizontal line test. So you're used to only doing the vertical line test to determine a function. Now we're going to do both. So we're going to take a look at these graphs over here. For our linear function here, if I did the vertical line test, you can see everywhere I draw a vertical line, it's only touching this graph one spot at a time. If I come through here and do horizontal lines, I know it looks kind of messy, but my horizontal line touches in one place. So it passes both tests. Therefore, it is one-to-one. Our second example is a parabola. So if I drew my vertical lines, you can see it passes the vertical line test. However, if I come across here with a horizontal line, it's touching that graph two places at one time. That fails the horizontal. So this is not one-to-one because it fails the horizontal test. Okay. The next graph, again, vertically, I would be fine. Horizontally, I would be fine as well. So this is one-to-one. Our last graph, vertically, we're fine. Horizontally, it fails. So not one-to-one. Okay. The last question says, which of the graphs are inverse functions? Well, it's an inverse function if it passes the one-to-one test. So this is an inverse, and this is an inverse. Okay. All right, the next thing we're going to do is we're going to talk about the steps for finding the inverse with a function. So step 1, you're going to replace that f of x with just a simple y, because we don't want to be trying to solve an equation with f of x. It just gets too confusing. Once you do that, for step 2, we're going to switch x and y. We'll solve the equation for y, and then we're going to replace y with that function notation. Okay? And I have students ask me all the time, do I really have to replace the y? Yes, you do. Okay? So this first example says find the inverse of f of x equals 2x plus 3. This is a linear function. Remember, mx plus b. We're not going to worry about this graphing part right now. Let's just worry about finding the inverse. So we've got f of x equals 2x plus 3. Step 1 says replace this f of x with y. So step 1. We're going to rewrite it, replacing that f of x. Step 2, switch your x and y. So step 2, I'm going to switch places with my x and y. Step 3 says solve this equation for y. So we want to get y by itself. So I'm going to take this x equals 2y plus 3. I'll subtract 3 from both sides. Then I need to divide by 2. So I have x minus 3 over 2 equals y. Step 4 says replace your y with your function notation. So we're going to use our function notation, and we're going to write x minus 3 over 2. So there's your inverse function. Okay. Let's do one that's a little harder. So we're going to find the inverse, and then we're going to find the value of 3 in the inverse function. So I'm going to do step 1 right here. So I replaced my f of x with y. Step 2 says switch your x and y. So we're going to rewrite this. X equals square root 5y minus 2 over 2. Step 3 says solve this equation for y. So we have a fraction. Anytime we have a fraction, we would multiply by the denominator to get rid of the fraction. So on this side we have 2x, and on this side we have the square root of 5y minus 2. Alright, so now we need to get rid of the square root. So in order to get rid of the square root, we need to square it. So what we do to one side, we got to do to the other side. Because this is in parentheses, you need to square everything. So 2 squared is 4, and then x squared. Squaring cancels out the square root, so we're left with 5y minus 2. We would add 2. So you have 4x squared plus 2 equals 5y. You're going to divide by 5. So you have y equals 4x squared plus 2 over 5. Don't forget that last step is to use your function notation. So that's the inverse. This means we're going to plug 3 into the inverse. So I've found the inverse. Now I'm going to substitute 3 in for x. So inverse of 3 is going to be 4 times 3 squared plus 2 over 5. And we can do this in our head. So 3 squared is 9. 9 times 4 is 36. Plus 2 is 38. So not a very pretty answer, but we'll take it. So 38/5. And then the next one. This is a cubic function. So again, I'm going to take that shortcut and I'm going to do step 1 right there. So I'm going to replace that f of x. Step 2, we're going to switch our x and y. So x equals y to the third plus 7. Now we're trying to get y by itself. So we would subtract 7 from both sides. So we got x minus 7 equals y to the third. So if I have y to the third and I want y by itself, I need to take the cube root of both sides. So that's going to leave me the cube root of x minus 7 equals y Last step, use that inverse notation. So cube root x minus 7. And there's our inverse. So now we're going to find the inverse of 7. So you see how when I write it under like this, the 7 replaces the x? That's exactly what you're going to do. You're going to replace the x, substitute. So we're going to have 7 minus 7 under the radical, which gives us the cube root of 0, and the cube root of 0 is 0. Okay?